morning, everybody. Welcome to the event. My name is Glenn Schulz. You might be able to tell from the accent that it's an American accent. I actually did live in the UK about 10 years ago. I lived about 150 miles southeast of here in Milton Keynes. I was working for Rockwell Automation at the time. I've been in the process of factory automation for most of my professional career, almost 30 years worth of doing that kind of work. So it's a pleasure to be in front of you and talk to you about a great technology like the FDT technology. Before we get started on the user benefits, just a brief comment on FDT as an organization, because we sometimes do get asked about that. The FDT group is an international nonprofit organization. So we're headquartered in Belgium. Personally, I live in Germany, but we have members around the world, as you saw on that slide. And all the activities of the FDT organization is funded by those members who pay dues to make sure that both the technical part of the standard keeps advancing forward. As was mentioned, adding more networks every so often, those kinds of things, new features to the standard. So we do a lot of technical work, but we also do a lot of marketing work, events like this, at trade shows and so on, to make sure people are aware of the technology and we get a chance to interact with the end users and the manufacturers in the industry to make sure we're encompassing everything we should be encompassing with the standard. So that's what we do as an organization. Very proud that we're member-led. People like Thomas are very dedicated to the activities of the FDT group, even though it's not his day job, as they would say. But we have many people like Thomas that make sure that the FDT standard is successful around the world. So let's get started a little bit, taking some of the things that Thomas talked about and turning it a little bit to a slightly different facet, and that's looking at it from the benefits from an end user perspective. What do you get out of it as an end user? So this won't be so much the technology side of things, but more your view as an end user. And right after this, we'll go into these breakout sessions, because first, we don't want to give you death by PowerPoint. But I think you've probably got enough terminology now and just enough feeling of what this stuff is that seeing it live and seeing it in different contexts will give you a much better appreciation of how it works. Plus, they're smaller groups, so it's easier to ask questions and crowd around things and things like that. So let's get on with it. So from an end user perspective, I've sat in the end user chair in my career as well, and I think one of the things that's great about the FDT standard is that it brings you freedom of choice. The term we often use is you get to pick best-in-class devices for your application. You're no longer forced to use certain devices just because that's what happens to work with that particular platform. As long as it's supporting the FDT standard, you can pick any device, any I/O structure, anything you'd like to add to that architecture to make a best-in-class application for your particular situation. I think another great thing about the FDT standard is its investment protection. Not only from our technology perspective, when we formed the FDT group, we made it very clear to the public that we would always maintain backward compatibility. It's very tempting when you drive technical standards to take great leaps forward, to take advantage of every last new bell and whistle of technology, and sort of leave behind all the tough issues that exist. We don't do that. We bring forward that compatibility every time we rev the standard. All the old DTMs, for example, work with the new version of the standard. You may not get all the new features, but at least you're ensured that you do not have to go retrofit your entire plant just because you want to take advantage of the latest FDT capabilities in some portion of your plant or facility. I think what really started the whole issue with FDT, rings very true today, is that it provides transparent access to data. Not just the inherent process values and I/O values in those devices, but all the diagnostic data that's in there. And that's often been the holy grail. Many people have looked at intelligent devices and say, boy, wouldn't it be great to leverage all that intelligence so I can actually schedule downtime and know what's going on in my facility before it happens. Now you finally get it with the FDT standard. And the nice thing is you don't engineer it. It's all delivered to you in the DTM from the people that know best about the intelligence and capabilities of that device. And then, as was pointed out earlier, it really spans the entire life cycle. You can start an FDT-based project without a single device in sight. You can build up a whole frame application, you can sit in your office, get it all configured, configure all the devices, and wait for equipment to show up before, and start the activity right after that. Download everything to the real equipment and you're off and running. You don't have to wait. But that carries throughout the entire life cycle. During the commissioning of the plant, we'll show this in some of the user stories and so on, where they saw significant reduction in commission time because they were able to pre-configure so that when it came time to turn on the devices, if they weren't at the right spot on the network, if they didn't respond, you immediately know something's wrong. You don't wire up the entire plant and then spend weeks and weeks ringing out end to end just to make sure that you've got all the I/O points right throughout the plant. The FDT standard helps you with that. And all the way through diagnostics and maintenance activity and calibration activity as well, as we'll see in some of the other user examples. So you've got this great freedom of choice. We're very proud of the membership of the FDT group, but we need to be clear. You do not need to be a member of the FDT group to create products that are compatible with the standard or to take advantage and use the standard in your facility. It's got nothing to do with membership. The membership simply helps the standard keep moving forward, but it's a publicly available standard, so anybody is free to use it. But for you as an end user, what this means is you have the absolute best-in-class portfolio of devices that you can select for your application. In fact, what you'll find is not only do you start looking at the capabilities of the specific device or I/O structure or whatever it is that you're looking at, but you'll start to look at the DTM to see, well, what features do I get in that DTM? Because that enhances the whole experience that you have with that device. So it was mentioned we support multiple protocols. We're always doing this. An interesting note about our standard is the engineers that created the standard realized from the outset that this was always going to be an ongoing issue, that there'd be new standards that come into the marketplace, that network standards would get revised on a periodic basis, and if we'd have to re-release hundreds of pages of our standard every time one of those networks moved a little bit in their technology platform, we could never keep up. So what they did was they separated the core specification from the communications protocols. So when a new communications protocol comes out, we simply issue what we call an annex, and all of the installed base of FDT applications can immediately take advantage of that new annex. So you can immediately add new networks to already installed configurations. The example of this most recently, I'm sure many of you follow the wireless type things that are going on in the industry. So HART came out, finalized their wireless standard for the HART network. We just recently re-released our annex for the HART network to include full support of that wireless standard. Similarly, the ISA 100 standard is another one that's very popular in the wireless field, and we're just about to release the annex for the ISA 100 standard. So that's how we keep it moving forward. We can keep adding networks at will as they come up. And by the way, you'll find several companies actually put their legacy networks on as annexes themselves. So while we don't support that particular network, they can add their own annex to make sure that their legacy applications are supported through the standard. Today we know that there's at least 60 different manufacturers supplying DTMs to the field. So again, as an end user, you've got this tremendous ability to choose devices. You can go and look at certified products on our FDT website if you'd like to look around and find what's available for your applications. We offer some nice filtering capabilities for networks and device classes and so on, so you can dig through that pretty quickly. There's at least 16 different system suppliers out there, and I can assure you this number is very light, but these are 16 that you can go and find readily with just a little bit of looking on our site or on the internet. A few were mentioned today, Pactware, FieldCare. You'll see some others today in the demonstrations that are another great examples of frame applications. And then sometimes these things are embedded in products and you don't even know it. One major robotics manufacturer uses FDT to configure and control their complete control cabinet in the automotive facilities. So you get a configuration tool to operate that robot, and you're not even aware it's FDT. But now that you've seen a little bit about FDT, if you happen to pick up their application, you'd immediately spot that it's an FDT application. But they kind of bury it under the hood. So for you, this simply means you've got a lot of opportunities to pick different kinds of devices, different kinds of frames, different kind of application to take advantage of all this intelligence in the devices. Here's an example of a more extreme case of that. In Singapore, there's a plant, a water treatment plant called the Changi Water Reclamation Project. Take a look at the scope of this particular project. Look at the number of devices that you see here. Just take a quick scan down the devices. I mean, look at this, 400 variable speed drives, so on and so forth. The application consists of these major vendors, and a lot of other vendors are part of the application. You can see they have quite a complex network structure as well, and this is spread out across a very broad field, as you typically have in large water treatment plants. This is the sole water treatment plant for all of Singapore now. That was all put in using the FDT standard. If you'd like to see more about that, you can visit our website. There's some more detailed stories out there. But it just gives you a sense as to what's the possibility with the FDT type technology. Freedom of choice, again, here you see it in the context of the catalog. This is a DTM catalog that you're looking at. Here we happen to be looking at another frame. This one is by Anderson Hauser called Field Care. But this is similar to what you'd see in all the frame applications. And we're only down to the H's down here at the bottom of the list. So you'd have to scroll quite a bit further to see the rest of the catalog. And so you can build that project tree that Thomas was talking about with all those different devices that are in that catalog. And then if you don't see what you want, you can go to that manufacturer's website and add more things to that catalog as well. So very flexible, but the end message to you again is complete freedom of choice. You notice there's nobody sitting here telling you which of these devices you can use in this application. They're all sitting there for you to choose. So from an investment protection perspective, upgrades, as I mentioned, is easily done. The standard is easily upgradable from our perspective. We did work with the Namur organization, which is dominant in Central Europe, headquartered in Germany. They are a chemical manufacturing organization that tries to put out, it's not quite fair to call them standards, but guidelines to the industry that says, these are the kinds of things that should be in tools and capabilities and configuring devices and so on. And if you Google this NE105, you'll actually find some nice information and suggestions in that specification. But you'll find that the FDT standard followed that guidance very closely so that we delivered the capabilities that Namur was looking for in the FDT standard. And as I mentioned, we support all phases of the life cycle. I think that'll become very clear as you see the demonstrations today, because each one of them focuses on a little different area of the life cycle. So take note of that as you're in the sessions here shortly. And then I think the most popular topic for us today, as we talk with end users around the world, is the advanced diagnostics that are available in these DTMs. And you'll get to witness some of that today. In the days before something like the FDT standard, if you had multiple networks deployed in your facility and suddenly you lost a whole group of devices, you'd likely send a network engineer out on the plant floor or out in the field somewhere, starting to trace cable to figure out what happened to that section of the network. Where did it go? Did it get hit by a forklift? Did somebody pull a plug? Was a terminating resistor missing? All sorts of bad things that can happen. Power supplies dropping off. Pay attention during the live demos, because you'll see you can now look at all of that information directly from an FDT frame and diagnose what's going on. And you'll see many other examples of these advanced diagnostics that are in DTMs. So this is probably the richest part now of the standard that's being realized, is these device manufacturers who know the device better than anybody else can build all this intelligence into the DTM to give you full diagnostics on the device, and not only tell you something's going wrong, but tell you here's possible causes, of what's going wrong, and here's possible remedies to fix this. And we'll take a look at that from some of the user stories as well. Communication protocols, it just goes on and on. We keep adding them to the standard. As Thomas mentioned, if you actually see a network protocol that you want to use is not represented in our portfolio, please let us know. We think it would be unusual at this point, but by all means, let us know if that's the case. We certainly see some unique things around the world. China has their own Ethernet kind of standard that's falling into disuse, so we've elected through our China organization not to add an annex to it just because it's falling off the radar. But maybe you've got something unique in your industry that we haven't looked at. Don't hesitate to let us know. Here's an example of investment protection from a BP plant in Germany. This just gives you one view of the type of diagnostics that are available. So you see at a very quick glance, the green things are saying, hey, everything's okay, but you've got a few other things here that you got to take a look at. And then most of these DTMs will then allow you further drill down. Okay, if that's the problem, what do I need to go do specifically? What can you recommend I do? And you'll see some of that in the demonstration sessions today. The transparent data access, I think one of the most powerful things is it exists in everything you do with a frame application. So if you're configuring a PLC using the PLC's tools and it's a frame and it's got the DTMs loaded, you get all the advantages there. But then you might have another frame that you just use for calibration and diagnostics on the bench so that your technicians have some good tools on the workbench to work with. You get all the same features there. You might have it on your higher level asset management system that's sitting next to your DCS system, similar to what, for example, Yokogawa would do in their architecture, and you get all those great features in that asset management system. So it's independent of where it exists in the architecture or how many copies of it and how many variations of it you use. You get all the same features throughout. And as Thomas mentioned, it's very clear from the thousands of installed bases now of FDT applications that there's no limit to the industry. There's nothing that we're aware of that's inherent in the specification that says, oh, this won't work in this particular industry. So take a good look at it and see if it's got everything that you're looking for from a standard perspective. So hopefully by now this term DTM is kind of programmed into you because that's the heart of the FDT standard. Those are the drivers that the manufacturer ships with it. You always want to take a look at the sophistication of the DTMs. Be honest, some things just don't need it. If you've got a simple temperature thermocouple probe, that DTM doesn't need to be too complicated. But if you've got a large horsepower AC drive, that's going to be a fairly sophisticated DTM because there's hundreds, if not thousands, of parameters that have to be set in modern AC drives. And the last thing you really want to do is sit there and go parameter by parameter. Okay, what do I have to set each one of these to? And you're spending most of your time learning what half the parameters are. You want a DTM that says, here's a wizard. Let me ask you questions about what you're trying to configure. Is this a pumping application? Is it a lifting application? Is it a hoist? What is it that this drive is configuring? And most of these DTMs will actually walk you through setting the majority of parameters for you and maybe just leave a few at the end that you've got to uniquely configure for your application. So take a good look at capabilities of DTMs. Thomas mentioned the best part about the standard is that we've got, even though we control where menus are and where certain features are in a DTM and everybody has to follow those standards, the main part of the DTM, the center part, is completely available for that manufacturer to really show off their stuff, to really let you see what the device is capable of, give you all the rich experience that you would want for it. So we don't constrain them. We allow them to show that they're a best-in-class device. That center area is theirs to do what they would like to use their imagination to do. Now the one thing we do is we do coordinate parts of it. We won't get into the details, but we have a thing called a style guide. And the style guide simply says to people that make DTMs and frames, if you're going to make a DTM, the menu always has to be here, the device plate information, serial number always has to be here, diagnostic stuff always has to be here. But again, then the style guide lets them take that center window and do what they want. The good thing for you then is if you install hundreds of DTMs in a frame application, you don't want to be bouncing around in every DTM trying to figure out where did the menu go and where's this tree structure on this one. And you want them to all kind of look the same so that you can navigate through them quickly and then let the wizards and the other things in the center show you the magic. So that's what the style guide does for you. This issue of transparency across the network, I think, is a huge one when you think about it from a user perspective. This issue that there's a communications DTM for the communications devices, and then there's just normal DTMs for the end devices. The beauty of this from an end user perspective is all of that is largely hidden from you as to how it works. All you have to do is say, I've got this particular gateway sitting here, and under that gateway, here's my devices. It figures out the rest for you. You're not spending hundreds of hours trying to figure out how do I talk to that. And even better yet is this issue of going through multiple networks is completely transparent. It's part of the standard, so the people that make the DTMs for these gateway devices know how to handle all that transparently for you. So no matter how many networks you stack up between wherever your PC, your frame application is, and the end devices, no matter how many layers you have to go through, as long as each gateway has a DTM associated with it, you'll transparently go through all of those networks to get to the end device. Completely transparent. Nothing you as an end user have to do to get there. This is a screenshot of nested communications. So in this example, somebody said, okay, I've got my host PC. Under that, I've got a gateway for Profibus, so they just installed the Profibus DTM there. And then they've got some devices that are hanging directly on Profibus. And then they said, oh, but under that, I've got a gateway to Heart, so they've got another gateway DTM plugged in there. We call those COM DTMs. And then here's some Heart devices under that. That's all this configuration it takes so that you can directly communicate from your host PC to this device just with some simple queries now using the device DTM. It'll just go right to that device through those networks. It's that easy. So the advantage to you is I've been in your seat in a few jobs where we always say, no, our standard for networks is, pick one, Heart. We're always going to use Heart. We're a Profibus shop. Everything we bring into this place, we're going to use Profibus. And you try to enforce it, and then sure enough, you got to put a new line in, and the machine you really want to buy comes with a different network. You can't get it any other way, so you make the concession, okay, this line or this process will have this different network in just because we have to get what we want. The nice thing is with the FDT standard, you add it at any time without any implications as to what you've done before. If today you really are a Fieldbus or Profibus user, and tomorrow, through whatever means, you have to take on some Heart capabilities, all you have to do is add the Heart communications gateway or the Heart scanner in your business, all on the same application. And best yet, you don't touch this configuration over here to do it. You just start with another gateway DTM or scanner DTM, and you're in business. It's that simple. So from an end user perspective, you've got this ability to keep your applications moving forward over time without being hamstrung by a certain network topology. So you have these examples as Thomas showed you where you're configuring a device directly. There are times where despite all this wonderful network activity, you need to get hands-on with the device, whether it's on a workbench or whether it's on a standalone application, whatever it might be. You've got these large control room capabilities, and all of this is with the same frame and the same DTMs to be able to do those varied types applications. So from an ease of use, I hope it's apparent to you that the engineering effort to get there is minimal. It's been set up so that most of the configuration is simple graphical drag and drop to create your physical network on the project tree. As a result, you can commission these projects much faster because you simply plug in the devices and start the commissioning process. From an FDT perspective, one of the things we help out with is we offer a certification program where manufacturers of DTM or frame applications can send their products to an independent test lab that runs it through a battery of tests to to say, are you compliant with the standard? So if it's a DTM, it checks to make sure that that DTM is going to talk to the frame properly and with all the methods that it has to. So they run it through a vigorous testing process, and if they pass that test, that certification lab then sends us a lab report, and we issue a certificate to that DTM or that frame that says, okay, that's certified, and then you find that listed on our website. We have some of our large users, like Chevron, for example, when they do their projects, they're always FDT projects, and they say it must be all certified DTMs. That's their way of ensuring that everything will play together when it arrives on site. It's not to say a non-certified DTM will have any problems. It's just another level of insurance that's available on the market. Plant asset management, I think you can also see that you've got, you can physically see what's going on in your plant. You've got all these advanced diagnostics, and as we'll show in some user stories, you can actually take a look at what's going on in the plant so that instead of saying our shutdown is always the third Monday of the fourth month of the year, that's when we do our shutdown, you can start to look at when do I need to do shutdowns or when do I need to do maintenance? How critical is this issue becoming? And that's all done through the DTM. So we'll take a look at some of those. Just a quick shot from Dow Chemical, a project they did in Spain. This is their statements. We asked them if we could have this slide. They did a presentation at a public forum. And this is what they saw in terms of this issue of commissioning. So they took advantage of being able to configure everything in advance of the equipment being available. So they saw a 40% reduction then in commissioning time and 80% less time spent in last-minute modifications. Okay, because since the network was all pre-built, you're getting most things shaken out from a topology perspective sitting on the desktop. You're not solving them in the field. So I think it's a great example of the kinds of savings that are possible. So from an ease of use perspective, I think Thomas has done a good job of describing the graphical interface is the key to this thing. It's not just text boxes where you've got to drop in data or some simple little graphics that might guide you through it. They're interactive graphics in many cases. Some of these radar gauge type applications, you tell it what kind of tank you have and it starts changing the shape of the tank to fit your application so you can visualize it better. Just fantastic things that are done with it. And as we say, the picture really does show more than all the words you could possibly put in the DTM. Frame application, again, as Thomas pointed out, one frame does the job. You will find frames that do different things or live in different parts of the architecture, but all the frames will largely look the same and function in the same way. So when you look at this over the whole life cycle of your facility, I think we've touched on most of these already, but from an engineering perspective, you get the advantage that you can do a lot of desktop work ahead of time, and then once you've got an operating plant, you still get the ability to look into that network, confirm what's going on, and so on. From a commissioning and startup, you can do that all after you configured it, or of course you could configure it in the traditional way once you have the equipment available. But you've also got all the diagnostic and status information immediately available. So if some address doesn't match up with what your configuration in the FDT frame said, you'll find that out right away. Or if somebody made a wiring error on some section of a coupler, you'll find that out right away as well. And then in operation, I think besides the great general information you get from the device, the asset management applications are phenomenal these days. And then I think service and maintenance, it's clear that they're exactly the kind of tools that these organizations are looking for to make their jobs easier. Sometimes we get asked about, what about DDs and EDDs? Because we're always talking about DTM. So if you're coming from the process side of the industry and you're using HART, FF, or Foundation Field Bus, you're probably familiar with the concept of DDs or EDD files. These are essentially text-based files that are used to configure a device. And so we're often asked, how does that fit into FDT? What do I do with those? Well, a while back, an organization here in Europe called WIB did a test of the FDT technology, and they were looking to see, now this is a couple of years ago, they were looking to see, is FDT ready to take over the things that that organization was looking for? And it was commissioned by Shell who was looking at the technology at the time. And you see, since then, Shell's become a member of the FDT group and is an avid supporter of the technology. But here was some of the bullets from their report. So they said, okay, first, it really does deliver the capabilities that it promised. It's the right platform for both configuration, operation, and maintenance. Okay, so they were confirming that it really does live over the entire life cycle of the plant. They did a little contrasting and said, in contrast, EDDL, is limited to kind of data access and parameterization. If you use it, it's okay, but it's not as advanced, obviously, as a DTM is. And then what their advice was at that time is really encouraging more vendors to do DTMs. Well, in those couple of years' times, we're now over 5,000 supported devices by DTMs, and that's just certified DTMs. There's many more DTMs and other devices out there that we don't know about, but from our certification perspective, that's what we've got. So it's an interesting report, and just to complete that story, we do take DDs and are able to process them in a DTM that's called an interpreter DTM. So if you got some old device out there that there's just no DTM available for, maybe the manufacturer's out of business already, but you've got a DD or an EDD for that device, there's a special DTM that'll suck that in and present that just like it looked in its old DD form. So it doesn't have all the fancy wizards and things, obviously, but at least you can, within the FDT application, configure and manage that device. So let me wrap it up. So I think from an FDT perspective, you can see there's great opportunities to reduce total costs of ownership as you deploy it. It gives you this ability to choose best-in-class devices, and you'll see that today, and you'll find it interesting that all of these demonstrations today are multi-vendor demonstrations. It protects the value of your plant asset. It's got the extensibility you need in terms of number of networks, devices, and so on, and it never abandons you in terms of what you've already got installed in your facility. All the data is transparently accessed, and I think you'd have to agree, once you see some of these DTMs working live, it's higher quality data than you could have ever imagined. It's not just raw, does this thing have a problem or not? You'll see it in the demonstrations. And then we are now a very worldwide accepted standard. Thomas mentioned IEC 62453. We're also an ISA standard, ANSI ISA standard in the US and North America, and we're a China GB standard in China. So we continue to expand our recognition as an international standard, so you can be assured that if you're a multi-plant operator in different parts of the world, that the standard will be universally recognized throughout the world. Dated slide. This year we've had a tremendous amount of uptick in certifications. In fact, it's been the busiest year ever for certifications for us. So we're now over 5,000 devices supported by DTMs, and there's well over 16 FDT frames out in the marketplace. So we hope you'll agree that by the end of this seminar that the FDT technology most likely fits your needs in your application.